legitimately that should be added to this and can be, but it's a very small quantity in comparison.
Yeah.
If we're looking at the rest of the structural materials for the wood, actually the analysis has not yet been completed, but the wood was harvested on site and using FSC rules. The peeled logs were actually used for roof rafters and trusses, and the square lumber was milled on site and air dried on site, and therefore the embodied energy and carbon emissions for the wood is anticipated to be low. So if this is actually a diagram looking at, or comparison, looking at what if the green one actually represents what the steel that was used in the Aldo Leopold Center for the connectors, and this is showing the total, the typical weight of the steel if the building was designed as a typical one-story commercial building. And so we noticed that also that would have actually amounted to, this is the amount of embodied energy and carbon emissions eliminated just by using the steel connectors and timber framing versus if they had used just a typical one-story reinforced concrete. And so I'm looking at basically the total embodied energy and carbon emissions for all the structural materials, which amount to about 1 billion BTUs. And for carbon dioxide emissions, looking at roughly 622,000 pounds CO2 for the structural materials. And then if we were to look at the building and assume that it would have about 100-year lifespan, we're comparing here in the second, in this part right here, the structural emissions and embodied energy, if we were to actually divide that by 100, so it would be roughly over that 100-year period, and comparing that to the operational emissions for the building per year as well. So that was the conclusion. I don't know, Mike, if you'd like to add to that.
This is actually something we just did in the last 2 days to try to come up with what all of this seems to mean. And I think if you recognize that this particular building, although it is using collected solar energy as the primary energy source annually, there is operational energy. So a large percentage of that operational energy is solar, but that's a 18 kBtu per square foot per year building energy demand, which is very low by any energy utilization intensity measures. It's still one of the lower ones in the country. And the emissions for the building structural system, which is not all of the energy and all of the structure, but what we began to look at, and certainly the main mass of the structure, if that's in a sense amortized over 100 years, that's really a small percentage of that amount, which is kind of surprising to a certain extent. Although there was a great effort to reduce the energy content in the structure by using the timber. If you look back up at the top, 92% of the embodied energy is reinforced concrete. And reinforced concrete was already mentioned once in the very first talk today as the major driver of carbon emissions of any building material, and it remains so. And there's nothing in this that shows that. In fact, we make it look much worse because we didn't think of anything different in the project for the foundation system, but worked very hard to come up with a different structural system going up, or a different structural system in terms of the masonry for the retaining walls. And so I think replacing reinforced concrete is still an area of research in which this could be a huge impact on new building construction. If you look at the carbon dioxide emissions, they're very small for the steel because it was only recycled steel. not in quantities, but even in percentages. With masonry, that's all transportation energy in a sense, so that's all of the gas consumption to the CO2 emissions there. I was a little bit surprised that the embodied energy wouldn't have been a larger percentage compared to the operational energy of the building. But some of you who may have been looking at this, you may have some critical comments or questions to add.
I think there's a product in Wisconsin that's made out of it's a concrete masonry block that's made out of fly ash and slag. But I don't know how, I forget what it was because they came into the presentation like a year ago. But it'd be interesting to know what the embodied energy on that one is comparatively.
Now, fly ash presents one interesting problem. If you take the third presentation we had this morning on the alphabets of materials, fly ash contains mercury. And I did a little, not only does fly ash contain mercury, but every single light that's on in this room contains mercury. And in the Alva Leopold Foundation, there's about 2.5 grams of mercury in the building. About half of it is in the lights, and about half of it is in the fly ash. And the fly ash is going to be embedded in that concrete for the life of the building. The mercury in the fluorescence is going to be recycled every 4 to 5 years. So over the life of the building, the fluorescents are going to be a much larger problem. So it's really nice to see LEDs really beginning to come to the fore as a new choice there. But I think one of the problems one has to really think about, which wasn't in this particular scope or focus, is how you address the issue of mercury, because mercury in the groundwater is definitely a huge environmental problem in terms of red material and in terms of the problems that mercury can cause through bioconcentration moving up the chain. So that's still, I think, a little bit of a concern in comparing whether or not to use fly ash as a material going in. Slag doesn't necessarily have the same amount of mercury, but I don't know what threadless materials are contained in slag.
I think just a level set. Does everybody understand what's being said when fly ash is used as a supplementary cementitious material? Everybody gets that? Everybody? All right. So I guess my question, since we've established that we're switching out Portland cement for fly ash, how many different concrete mixes were evaluated? And did you guys benchmark what you accomplished against what the footprint would have been if you hadn't used fly ash?
This was a comparison to just not using any fly ash or slag. Now, there were 3 different mixes that were used on the site, and those mixes were varied primarily in the cement contract 10 for the string, but then also in the percentage of slag and fly ash, and we had those for all of the mixes. So this was simply taking all of the fly ash and slag out and just saying, what if it was all Portland cement? So
roughly a 20% drop in...
Yeah, slightly less than 20, maybe 18%.
Yeah.
As a drop in the embodied energy, slightly larger drop in the carbon, because the manufacture of cement includes a rather large product of the chemical process going from calcium carbonate into cement, getting CO2 coming out. So it's not just the CO2 from the energy of combustion consumption, but there's also CO2 in the chemical process of making cement. So the savings in terms of CO2 emissions is pushing closer to 20 to 25%.
And that makes sense. So the follow-on question is there something else that could have been done in the design optimization to lower the embodied carbon by 20-25%? Could you have used 20% less concrete somehow?
I think one of the bigger ones is that you start to look at where do you really need to use cement. For example, the masonry that came in for the reinforcement was a decision made during construction when the masonry contractor on site said, I got a whole bunch of stone that's just sitting out in the quarry. And so there was a switch in the design process inside to use that masonry for all the retaining walls. There's no reason to have any of the exterior slabs that are out there. That all could have been a walking gravel, some other kind of a masonry on site. So I think what you want to look at is where can you use a different material, especially in terms of hardscape on site. And that's probably one of the places that we could have done better as a design team in the sense of the concrete going around, but that's exactly the right kind of question.
Yeah, I'm certainly not criticizing you guys, because this is a fabulous project, right? But one of the things that I'm concerned about, and one of the things that I'm hoping analyses like this and more life cycle thinking will introduce into our